We're starting our study of Chapter 2, Section 4, so Section 2.4, and as always, whenever we start a section, we always deal with the learning targets, and the learning target for today is to define positive and negative fractions. We're going to divide positive and negative fractions. We need some terms before we can do that. The first one that we need is called multiplicative inverse. A number and its multiplicative inverse is equal to 1. Another way to say multiplicative inverse is to say its reciprocal. For example, then, if I have 1/8, its reciprocal is 8 over 1. I move the denominator to the numerator to the denominator, and it becomes its reciprocal. The product of reciprocals is 1. Product of reciprocals is 1. All right, so I've got the number 3/4 times, and I want to multiply it by its reciprocal. Well, its reciprocal is going to be 4/3. I move the 4 up and the 3 down. When I go to multiply these, of course, the 3's cancel, the 4's cancel, and I'm left with 1 over 1, which is equal to 1. We can say exactly the same thing about it in algebraic terms. We can say that a over b times b over a, its reciprocal, is equal to 1, but we do have to add this one more definition, and that's to say that a and b cannot be equal to 0. At no time can we have 0 as a denominator. Well, let's do this problem. Here we've got the inverse of a negative 2 and 4 sevenths, and we want to multiply, or we want to know its multiplicative inverse. First thing I have to do is write it as an improper fraction. Well, if I work as this an improper fraction, that becomes 14 plus the numerator of 4 over 7. And again, it's negative, so it would be a negative 18 over 7. Is that number rewritten as improper? Its multiplicative inverse then would be 7 over a negative 18. So its multiplicative inverse is 7 over a negative 18. Same idea, but this time down here, we have a negative 1 5/6. Well, I have to write it as an improper fraction, so I'm going to take 1 times 6, and I'm going to get 6 plus 5. So 6 plus 5 over 6, and of course it's negative. So 6 plus 5 is 11 over 6, and it's negative. So that's the number itself. Its multiplicative inverse, or its reciprocal, would be 6 over 11, and one of them has to be negative. So its multiplicative inverse is a negative 6/11. To divide by a fraction, multiply it by its multiplicative inverse. So if we're going to divide by a fraction, we need to multiply. We change it to a multiplication problem, but we multiply by its multiplicative inverse. So example, if I have 2/5 divided by 3/4, that's the same thing as saying 2/5 times 4/3. All right, if I'm multiplying fractions, of course, I just multiply the numerators, and I get 2 times 4 is 8. I also multiply the denominators. I get 5 times 3 and get 15. 8/15 is then the quotient for this original problem. In algebra terms, we can say that a fraction a over b divided by c over d is the same thing as saying a over b times d over c. See, I just flipped these two around. I took its reciprocal, and of course it would be a times d over b times c would be the product of those two. Let's do it in real life here. Let's do a problem with it. I've got 2/7, 2 over 7 divided by a negative 8/9. Well, 2/7 then times 9 over 8, and I bring along the negative sign. I can multiply the numerators. 2 times 9 is 18. And 7 times 8 would be 56. I look for a way to reduce that. I can at least divide 2 into the 18 and get 9 in the numerator. And I can divide 2 into the denominator and get 28. And of course, it's negative. I don't see any other reductions that we can do there. Let's work on this problem. I have a negative 3/5 divided by 9/10. So it's a negative 3/5 times 10 over 9. I'm going to do a little bit of simplifying before I multiply these, because I can know that I can divide a 5 into there and a 5 into there and get 2 here and a 1 there. I can divide a 3 in there and get 1 and a 3 into there and get 3. So I've got 1 times 2 is 2 and 1 times 3 is 3. I get 2/3, but I do have to bring along my negative sign. So it's a negative 2/3. I'm going to work on this top problem here where it's 3 1/4 divided by a negative 2 1/8. I need to write those as improper fractions, so I'm going to take 4 times the 3, get 12. I'll end up with 13/4 divided by 17/8, but of course that one of those is negative. I'm going to take the reciprocal of this and multiply, so I've got 13 over 4 times 8 over 17, bring along the negative sign. This can, 2 can go in there 2 times, 2 can go in there 4 times. So I've got 13 times 4. 13 times 4 would be 52. Over 17 times 2 would be 34. And of course it's negative. I cannot leave that as an improper fraction. So I need to, or a mixed, I need to write it as a mixed number. 34 will go into 52 one time. 34 will go into 18. Well, it just is a remainder of 18. So I'm going to say it is 1 and 18/34. And of course it's negative. Will anything go into 18 and 34? Yes, it will. So it's a negative 1. This could become 9. This could become 17. So it's 1 and 9/17. It's negative 1 and 9/17. One summer day, a cinema shows a hit action movie repeatedly for 12.5 hours. It takes 150 minutes to run the movie and to prepare for the next showing. How many times does the cinema show the movie that day? Well, I'm going to take it's the 12.5 hours that they ran it divided by the time it takes to run the movie. But 150 minutes, I want to write it in hours rather than minutes, so I'm going to change that 150 minutes to 2.5 hours. 2.5 hours. I need to get rid of the mixed numbers here, write them all as fractions. So this would become 25 halves divided by 5 halves. Okay, I'm going to flip it over, flip this part over, so I can be multiplying instead of dividing. 25 over 2 times 2 over 5. Do a little bit of reduction. The 2's cancel. 5 will go in there 5 times. 5 will go in there 1 times. I've got 5 times 1. 5 times 1 will give me 5 in my numerator, and 1 times 1 will give me my denominator of 1. That means they show it 5 times during the day. 5 times during the day. It took 5 members of the Johnson family 10.5 days to paint the 7 rooms of their house. At this rate, how long will it take the 4 members of the Rise family, to complete the similar task? Well, the 1 family had 5 members times 10.5 days. That's how long it took them. And an equal task will be completed by the 4 members of the other family. All right? They want to know how many days it will take. I'm going to do my multiplication here. I'm going to, first of all, write this part as a improper fraction. 10 would be 21. 21 halves. I'm sorry, 21 halves times 5 over 1. 5 times 21 would be 105 over 2. That's how long it took the Johnson family to do it. And I'm going to then divide that. I'm going to say that's equal to 4 times x for the Rees family. So I'm going to divide both sides by 4. So I'm going to divide that side by 4. In fact, what I'm going to do is I'm going to say 105 over 2 times the reciprocal of 4, which is 1/4. Looking for a way to reduce this, nothing comes up easy. It looks like it's 105 over 8. 105 over 8. I don't see any good easy reductions there, so I'm going to go back and write it as a mixed number now. 105 divided by 8. Looks like 8 will go in there probably, well, I'll go 1 time 8, subtract, get 25. 25. It'll go in there 3 times, so that'd be 13 with a remainder of 1/8. So it'll take 13 1/8 days to complete that project. Trick question. I'll tell you right up front, it's a trick. If 3 men could dig 3 holes in 3 days, 3 men, 3 holes in 3 days, how long does it take 1 man to dig 1/2 of a hole? I'll let you work on that, and we'll come back and talk about that one in class.